Okay, question 9 is given us a function here, and it says that the curve, show that the curve has two distinct stationary points. So we need to show where stationary points are, and we need to differentiate this. So that's testing our quotient rule knowledge. So the quotient rule says we differentiate the top one, which is just going to be p, and leave the bottom one alone. We then subtract the differential of the bottom one times by the top one. So that's going to be 2x times by px plus q. We would then divide by the square of the bottom one. And we want that to be equal to 0 at stationary points. If we've got a fraction equal to 0, the top must be 0. It doesn't matter what the bottom was or is, as long as that's not 0. This won't ever be 0 because we're adding on a number to a square number and then squaring it, so we don't have to worry about that. So we're just concentrating on the top. We can write down, and in fact I'm going to expand the brackets as well, so we've got px squared plus 3p minus 2px squared minus 2qx, and that needs to equal 0. So if we tidy that up, px squared take away 2px squared is going to be negative px squared minus 2qx plus 3p equals 0. So this now looks like a quadratic, and we need to show that that quadratic will always have two solutions. In other words, it will always cross the x-axis at 2 points. And we know that the discriminant determines how many times a graph crosses the x-axis. If the discriminant of this is positive, it will cross the x-axis twice. It has to be greater than 0. b squared minus 4ac needs to be greater than 0. So if we find the discriminant, then we're going to get b squared, that's going to be minus 2q squared minus 4 times a minus p times c, which is 3p. And we need that to be greater than 0 if there's going to be two solutions. So if we simplify this, we're going to get 4q squared plus 12p squared. So because this is, we're squaring a number here and we're adding on the square of another number, this will always be positive. Because at the beginning of the question, it said that p and q were not 0. So this will always be positive for all p and q because they're not equal to 0. Therefore, two solutions to the quadratic which means there'll be two stationary points.